procedure for installing PVC conduit in ground encased in concrete involves several steps to ensure proper protection for electrical circuits. This explanation is based on a 480 volts AC, 3-phase, 60 Hz, 50 amp circuit running 950 feet. Firstly, gather your materials. You'll need PVC conduit. A minimum of Schedule 40 is recommended. You'll also require concrete mix, form boards, gravel or crushed rock, sand, and optionally, rebar for additional strength. Now, let's get started. 1. Excavate the trench. Dig a trench approximately 24 to 36 inches deep and 12 to 18 inches wide. The depth may vary depending on local regulations and soil conditions, so always check your local codes. 2. Lay the conduit. Place a 2-inch layer of gravel or crushed rock at the bottom of the trench. This layer provides drainage and helps protect the conduit from direct contact with the soil. Lay the PVC conduit on top of the gravel. If you are installing multiple conduits, maintain a minimum of 6 inches of space between them. This spacing helps to dissipate heat and prevents interference. 3. Prepare the concrete form. Erect form boards on both sides of the trench, leaving a minimum of 4 inches of concrete cover above the conduit. This concrete cover protects the conduit from physical damage and provides insulation. Secure the form boards with stakes or ties to ensure they remain in place during the concrete pour. 4. Fill with concrete. Mix the concrete according to the manufacturer's instructions. Ensure the mix is consistent and workable. Pour the concrete into the form, filling it to within 2 inches of the top. Use a vibratory screed or hand tamp to remove air bubbles and ensure a solid fill. Air bubbles can weaken the concrete and compromise its protective properties. 5. Lay reinforcement, which is optional. If additional strength is required, place rebar in the concrete. The rebar should be at least 0.5 inch in diameter and spaced no more than 18 inches apart. The rebar provides tensile strength to the concrete, preventing cracks and increasing its load-bearing capacity. 6. Fill to grade. Pour additional concrete to fill the remaining space and bring the concrete level with the surrounding ground. Smooth and screed the concrete surface to create a level and uniform finish. 7. Cure the concrete. Allow the concrete to cure for at least 28 days before backfilling or digging near the conduit. Curing is essential for the concrete to reach its full strength and durability. Keep the concrete moist during the curing process to prevent cracking. Now let's address some specific considerations for your 480 volts AC circuit. Use PVC conduit with a voltage rating of 600 volts or higher. This ensures the conduit can safely handle the voltage of the circuit. Install a grounding rod at the pump station and connect the conduit to the grounding system. Proper grounding is essential for electrical safety and helps to prevent electrical shock. Ensure that the conduit is buried at least 18 inches below the surface in accordance with local regulations. This burial depth provides protection from physical damage and ensures compliance with electrical codes. Backfill the trench with sand or other non-conductive material to provide further protection. Sand helps to cushion the conduit and prevent damage from rocks or other debris. Remember to always consult with a qualified electrician or engineer to ensure that your installation meets all applicable codes and regulations. Electrical work can be dangerous, and it's important to take all necessary safety precautions. Furthermore, ensure all work is performed according to the National Electrical Code or NEC. The NEC provides detailed guidelines for electrical installations, including conduit burial depths, conductor sizing, and grounding requirements. Let's elaborate on the materials. PVC conduit is chosen for its resistance to corrosion and its ease of installation. Schedule 40 is a common choice for underground applications, but Schedule 80 provides even greater protection against physical damage. Concrete mix should be designed for underground use and should have a compressive strength of at least 3,000 pounds per square inch. The concrete should be properly mixed and free of large aggregate that could damage the conduit. Form boards can be made of wood or metal and should be strong enough to support the weight of the concrete. Form boards should be properly aligned and secured to prevent the concrete from leaking out. gravel or crushed rock should be clean and free of debris. The gravel should provide good drainage and should be compacted before the conduit is laid. Sand should be clean and free of organic matter. The sand should be used to backfill the trench and provide additional protection for the conduit. Rebar should be sized according to the load requirements of the concrete. The rebar should be properly spaced and tied together to provide maximum strength. When excavating the trench, be sure to locate any underground utilities before digging. Call your local utility companies to have them mark the location of their underground lines. Use caution when digging near underground utilities to avoid damaging them. The trench should be wide enough to accommodate the conduit and the concrete encasement. The trench should also be deep enough to meet local code requirements. When laying the conduit, be sure to use proper fittings and connectors. The fittings should be watertight and should be properly installed. Use conduit straps to secure the conduit to the gravel or crushed rock. If you are using multiple conduits, be sure to maintain the proper spacing between them. When preparing the concrete form, be sure to use a release agent to prevent the concrete from sticking to the form boards. The release agent should be applied evenly to the form boards before the concrete is poured. The form boards should be properly braced to prevent them from moving during the concrete pour. When filling with concrete, be sure to pour the concrete in layers. Each layer should be vibrated or tamped to remove air bubbles. The concrete should be poured evenly around the conduit to ensure that it is completely encased. When laying reinforcement, be sure to overlap the rebar at the joints. The rebar should be tied together with wire ties. The rebar should be positioned so that it is completely encased in the concrete. When filling to grade, be sure to use a screed to level the concrete surface. The concrete surface should be smooth and free of any bumps or ridges. The concrete should be sloped slightly to allow for drainage. When curing the concrete, be sure to keep the concrete moist for at least 7 days. The concrete can be kept moist by covering it with wet burlap or by spraying it with water. The concrete should be protected from freezing temperatures during the curing process. Let's further address specific considerations for a 480-volt circuit. Using PVC conduit with a voltage rating of 600 volts or higher is crucial for safety. The voltage rating indicates the maximum voltage that the conduit can safely handle. Using a conduit with a lower voltage rating could result in electrical breakdown and pose a safety hazard. Installing a grounding rod at the pump station and connecting the conduit to the grounding system is essential for preventing electrical shock. The grounding rod provides a path for fault current to flow back to the source, tripping the circuit breaker and energizing the circuit. The grounding system should be properly installed and tested to ensure that it is functioning correctly. Ensuring that the conduit is buried at least 18 inches below the surface is a requirement in many local codes. The burial depth provides protection from physical damage, such as from digging or vehicular traffic. The burial depth also helps to maintain a consistent temperature for the conductors, which can improve their performance and longevity. Backfilling the trench with sand or other non-conductive material provides an additional layer of protection for the conduit. The sand helps to cushion the conduit from rocks and other debris that could damage it. The sand also helps to dissipate heat and prevent the conduit from overheating. Remember, electrical work should only be performed by qualified professionals. If you are not comfortable working with electricity, hire a licensed electrician to do the job. Always follow all applicable codes and regulations when performing electrical work. This will help to ensure that the installation is safe and reliable. Consider the environmental factors as well. In areas with harsh winters, the concrete encasement can help to protect the conduit from freezing temperatures. In areas with high water tables, the concrete encasement can help to prevent water from entering the conduit. In areas with corrosive soils, the concrete encasement can help to protect the conduit from corrosion. Conduct a thorough inspection of the completed installation. Check the conduit for any signs of damage. Check the concrete for any cracks or voids. Check the grounding system to ensure that it is properly installed. Test the circuit to ensure that it is functioning correctly. Document the installation. Keep records of the materials used, the installation procedures, and the test results. This documentation will be helpful for future maintenance and repairs. Consider using a tracer wire. A tracer wire is a small gauge wire that is buried alongside the conduit. The tracer wire can be used to locate the conduit in the future using a cable locator. A tracer wire can be helpful if the conduit needs to be repaired or replaced. Consider using warning tape. Warning tape is a brightly colored tape that is buried above the conduit. The warning tape serves as a visual warning to anyone digging in the area that there is an underground electrical line. Warning tape can help to prevent accidental damage to the conduit. Consider using a concrete additive. There are a number of concrete additives that can improve the performance of the concrete. Some additives can increase the strength of the concrete, while others can improve its resistance to water or corrosion. Choose a concrete additive that is appropriate for the specific application. Consider using a flexible conduit connector. A flexible conduit connector can be used to connect the PVC conduit to the equipment at the pump station. A flexible conduit connector can help to absorb vibration and prevent damage to the conduit. Consider using a pull box. A pull box is a box that is installed in the conduit run to make it easier to pull the conductors. A pull box should be installed every 100 feet or so in a long conduit run. Consider using a lubricant. A lubricant can be used to make it easier to pull the conductors through the conduit. Use a lubricant that is specifically designed for use with electrical conductors. Be aware of the potential for condensation. Condensation can form inside the conduit, which can damage the conductors. To prevent condensation, seal the ends of the conduit with duct seal. Also, consider installing a drain in the conduit to allow any condensation to escape. Consider the thermal expansion of the conduit. PVC conduit will expand and contract with temperature changes. To accommodate this thermal expansion, use expansion fittings in long conduit runs. Expansion fittings will allow the conduit to move without putting stress on the connections. Follow lockout-tagout procedures. Before working on any electrical equipment, be sure to follow lockout-tagout procedures to energize the circuit. Lockout-tagout procedures will help to prevent accidental electrical shock. Use personal protective equipment. When working with electricity, be sure to wear personal protective equipment, such as safety glasses, gloves, and a hard hat. Personal protective equipment will help to protect you from electrical shock and other hazards. Work with a buddy. When working with electricity, it is always a good idea to work with a buddy. A buddy can help you to stay safe and can provide assistance in case of an emergency. Use a ground fault circuit interrupter or GFCI. When working with electricity in wet or damp locations, be sure to use a GFCI. A GFCI will help to protect you from electrical shock. Inspect your tools. Before using any electrical tools, be sure to inspect them for damage. Do not use any tools that are damaged. Use the right tool for the job. Use the right tool for the job. Using the wrong tool can be dangerous and can damage the equipment. Stay focused. When working with electricity, it is important to stay focused and avoid distractions. Distractions can lead to mistakes and accidents. Take breaks. When working with electricity for long periods of time, it is important to take breaks. Breaks will help you to stay focused and avoid fatigue. Know your limits. Know your limits. Do not attempt to do any electrical work that you are not qualified to do. Hire a qualified electrician to do the work for you. Respect electricity. Respect electricity. Electricity is a powerful force that can be dangerous if it is not handled properly. Always treat electricity with respect. By following these procedures and taking the necessary safety precautions, you can safely install PVC conduit in the ground encased in concrete for your 480 volts AC circuit. This will provide long-lasting protection for your electrical system.